Hi, dear children. Good morning to you all. Welcome back to science class. In the last session, we are already discussed about the series combination, okay, or registers in series. So, two or more registers can be connected end to end or between the 2 points is called as registers in series. So, in resistance in series, almost all some of the important points I have discussed with you. I have discussed already with you, especially the equivalent resistance is equals to the sum of the individual resistance of the resistor, and the potential difference is different and the current is same. Now we are going to study about one more new concept, that is the parallel combination or resistors in parallel combination, right? When two or more resistors are connected simultaneously between the 2 points, this is one point and this is one point simultaneously, so this is called as what? Parallel combination or resistors in the parallel. This is the schematic diagram of what? The resistors are in parallel combination. So here R1, R2, R3 are the resistors in a circuit, and here the current is different in the parallel combination, right? So I1 current in the resistance 1, resistor 1, I2 current in the resistor 2, I3 current in the resistor 3. And as you know already, this is the key and battery, ammeter and the voltmeter. Voltmeter is a device measure the potential difference. It is a device which is measure the electric current. So this is the schematic diagram. Then in parallel combination, what happens? So especially the total current we taken as I equals to I1 plus I2 plus I3, right? And similarly, according to Ohm's law, what happens here? I equals to V by R. Therefore, I1 equals to V by R1, I2 equals to V by R2 and I3 equals to V by R3. So, here V means what? The potential difference is the same in across the each resistor in the parallel combination, right? So, if R is the equivalent resistance, so I equals to V by R. Thus, V by R equals to V common taken means 1 by R1 plus 1 by R2 plus 1 by R3. So here we get cancelled. We have 1 by R equals to 1 by R1, 1 by R2 and 1 by R3. This is the main formula for the resistors in the parallel combination. Dear students, now we are going to study some important points regarding to the parallel combination or the parallel. Look at here, the first one. What is the first one? The reciprocal of equivalent resistance. Here RP means resistance in parallel or resistors in parallel. So the reciprocal of the resistance in parallel is equals to the sum of the individual resistance. Sum of the individual resistance of the resistor. This is the first point. And second one, the reciprocal of the equivalent resistance is lesser than the or less than the each resistor or resistance of the each resistor in the parallel combination. And third point, the current is different in each resistor. Here I said already, I1 is different, I2 is different and I3 is different. So the current is different in the each resistors in the parallel combination. At last, the potential difference is the same in every resistors in the parallel combination. Dear students, this is about the resistors in parallel combination and some important points regarding the parallel combination. So after watching this video, better you have to make a differences between the series combination and the parallel combination. Dear students, now applications of parallel combination in daily life. So already we discussed series combination as well as parallel combination. Then which is very useful in our daily life, right? So compared to series combination, parallel combination is very useful in our daily life. Why? Because in series combination, if the circuit is broken or cut in anywhere, the whole circuit will stops. Means the current is stops the flowing. That is why the whole circuit is stops the flowing of electricity. But in the case of the parallel combination, if anywhere the circuit is broken, only the particular part will stops the work. Remaining part will be working as it is continuously. So this is the very important point to use of parallel combination in our daily life, right? So here especially the circuits in the parallel combination divides the electric current in each component among the component requiring different amounts of current. So likewise parallel combination in a circuit divides the current in the among the components so that can be have the necessary amount of current. Means the system can be operate properly, it needs the necessary amount of electricity. That is why, and the main reason is use the parallel combination is mainly it divides the current in the different components or different appliances. They work properly as they need the amount of or necessary amount of electricity. That is why we have to use parallel combination in our household activities or in household circuits.